Well, good afternoon, and welcome to NASA headquarters in Washington, D.C. My name is Dwayne Brown with the Office of Communications. On July 14th, NASA will make history with a spacecraft flyby of an object after traveling almost 10 years and more than 3 billion miles away from Earth. That object is Pluto. Today, we have a two-part panel briefing to discuss plans and related upcoming activities about the agency's historic New Horizons spacecraft flyby of the Pluto system this summer. Briefing 1 will describe the mission's goals, scientific objectives, and encounter plans, including the types of images and other data that we expect and when. We'll take a 30-minute intermission, and then we come to panel 2. Well, we'll talk in more detail about this incredible spacecraft and some of the challenges the spacecraft could encounter. After our presentations, we'll take questions from here at headquarters, our phone lines across the country, and of course the social media. And social media, ladies and gentlemen, is all abuzz about NASA's New Horizons mission. And of course, send those questions in on hashtag AskNASA. And all of the information here and about this incredible mission will be on the website at www.nasa.gov/New Horizons. Well, before I introduce you to the panelists and we get into this incredible mission, to set the stage of this historic mission, it's my honor to ask to come to the podium, 5-time space shuttle flown astronaut and the head of NASA's Science Mission Directorate, in which Pluto is part of his vast portfolio. Please welcome, ladies and gentlemen, the head of SMD, Science Mission Director and astronaut, John Grunsfeld.
Thank you very much, Dwayne. When you're the head of the Science Mission Directorate, the steward of this amazing program that includes the whole rest of the universe, it's easy to think about, the solar system is one small part of it, but it's an amazing, amazing journey that Pluto New Horizons has been on for almost the last decade. Our mission is to innovate, explore, discover, and inspire. With Messenger around Mercury, a fleet of Earth observation satellites around our home planet, gathering critical data of the Earth system, MAVEN, Odyssey, Mars Reconnaissance Orbiter, Curiosity and Opportunity at Mars, Dawn at the Dwarf planet Ceres, Juno on its way to Jupiter, Cassini at Saturn, Rosetta at Churyumov-Gerasimenko, Voyager at the edge of the solar system. It's hard to imagine a more exciting time in solar system exploration. But it will get even more exciting this summer with the encounter by Pluto New Horizons as it flies through the Pluto system and gives us our first close-up and personal view of the planet Pluto. The U.S. has been a leader in space exploration of our solar system, being first to successfully make it to every planet in our solar system, out to Neptune so far. And the Pluto New Horizons mission will cap off our grand tour de solar system. I have absolutely no doubt that the Pluto system holds many surprises for us, and the Pluto New Horizons team is ready for it. We're entering a new realm as the Pluto New Horizons zooms towards Pluto, the realm of the Kuiper Belt, a region that holds the story of the beginnings of our solar system. Pluto and its moons and the other objects that we will discover represent a new class of targets for our solar system exploration and beyond. And we're out there. So with that, I'll hand it back to Dwayne to introduce the panel. Thank you very much. I'm very excited.
Okay, fasten your seatbelts. Here we go. First up, you're here. Jim Green, Director of Planetary Science, NASA headquarters. Alan Stern, New Horizons Principal Investigator, Southwest Research Institute, Boulder, Colorado. William McKinnon, New Horizons co-investigator, Washington University, St. Louis. Kathy Olkin, New Horizons Deputy Project Scientist, also at the Southwest Research Institute. And with that, I'll toss it to you, Jim.
Thank you very much, Dwayne. You know, when we look back at the 50 years of planetary science, we've methodically explored our solar system, and we've done it in a very unique way. We've started out with flybys. We fly by all the major objects. That's our major first step in doing the early reconnaissance of our solar system. From the flybys, we learn then what we want to go back to. We then orbit. More complicated missions are land, rove, and even return samples. As John mentioned, we are at the stage now of completing that first initial step by flybying Pluto and the Pluto system. We've used the Mariners for all the terrestrial planets, the Voyagers and the Pioneers for the outer planets, and now the New Horizons missions will complete that next step, that initial flyby of Pluto. What a historic time we have. And in fact, the mission last week on April 9th took a good look at Pluto again and Charon. And if I can have my first image. Here we see with the Ralph instrument, visual imager, color imager, the first really great color observation of Pluto and Charon. Now, Charon's in the lower left quadrant, and you can see immediately a number of major differences. Pluto seems to be very bright. It seems to be redder. It's not as dim, or Charon is now dimmer than Pluto. So these are already tantalizing glimpses of this system. What is it telling us? Is it telling us more about the atmosphere of Pluto? Does it tell us anything about Charon, its surface? Perhaps it has an atmosphere also. So the compositional differences, New Horizons will examine. The geological differences, New Horizons will examine. And it will observe all sorts of other wonderful things in that system, including all the smaller moons. Now, we are at a great historic stage in this mission. And so today's press conference, we're going to methodically provide you some background and bring you along with the exciting mission as we have scripted it and as we believe it will be pulled off. But I know there will be fabulous surprises along the way. And so to get us started, let me now pass it to Alan Stern, the principal investigator of the New Horizons mission. Alan?
Thank you, Jim. Well, welcome everybody. We're excited. It sounds like science fiction, but it's not. 3 months from today, NASA's New Horizons spacecraft will make the first exploration of the Pluto system, the Kuiper Belt, and the farthest shore of exploration ever reached by humankind. And today we're going to tell you in great detail about how the mission came to be, what the mission consists of, what kind of science we're going to do and why we're doing it, and then we're going to tell you about what images you will see come to the ground, and other things as well. A full set of briefings, and we look forward to your questions as well. If I can have the next time step, I want to say that this mission harkens back to the 60s and the 70s and 80s when we first opened up the solar system, as Jim said, with historic missions named Mariner and Voyager and others like Pioneer. And it's really been since 1989 and the conclusion of the Voyager program at Neptune since we've gone to a place like going to Pluto, to go farther, to go to a planet that's beyond, to see a point of light, as Carl Sagan said, turned into a planet before our very eyes in a matter of weeks. This is an amazing opportunity for science education. It's an amazing opportunity for all of us, and we are so looking forward to it as scientists to go exploring this whole new realm of the solar system and this new miniature planetary system called Pluto and its satellites. This is a mission of firsts. Firsts, of course, it's the first spacecraft to the Pluto system, but it's also the fastest spacecraft ever launched. It's the first mission to a binary planet. It is the first mission to the Kuiper Belt, the first mission in NASA's New Frontiers program that Jim is the steward of. It is the first PI-led mission to the outer planets, and something I'm particularly proud of. New Horizons is the first mission launched in the planetary program to carry a student-built instrument. And you'll hear more about that as well. Let's turn to the next time step, and the one after this, which shows you a series of mission studies that were done beginning in 1990 to formulate mission concepts for Pluto. And we're showing this to you today because we want to emphasize how long the scientific community in the United States has wanted to explore these worlds. Beginning with Pluto 350 and then extending to Mariner Mark II, Pluto Fast Flyby, Pluto Express, and then Pluto Kuiper Express, NASA conducted a whole series of increasingly refined engineering and science studies for how to go about a flyby reconnaissance. And then NASA conducted a competition, an open competition in 2001 between teams, and our team, New Horizons, was fortunate to win. In the years following that, from 2002 to 2005, we designed, built, and tested the spacecraft we're going to be telling you about and its instrument payload, launched it in 2006, as John and Jim told you, on an epic, almost 10-year voyage across the entire expanse of our solar system, the first such voyage of the 21st century. If I can have the next time step, I'm going to be telling you a little bit now about the Kuiper Belt. And the dot that you see at the lower portion of the screen that's in orbit is Pluto, which was discovered in 1930 and was sort of without context until the early 1990s when objects in the Kuiper Belt, which you see being revealed in this video, began to be discovered. This is an amazing and fundamental change in our view of the solar system. Before the 90s, we didn't know that this third zone of the solar system existed. We knew about the inner zone of the terrestrial planets, and we knew about the giant planets, what we now call the middle solar system. But this new third zone, as John Grunsfeld told you, a relic from the era of planetary formation, has so much new to teach us. It is the largest structure in the planetary system, containing comets like Rosetta's target, containing the building blocks of small planets, and small planets, not just Pluto, but others as well. So if I can have the next view graph, I want to talk a little bit about that new population. Beyond being the third zone of the solar system, the Kuiper Belt taught us that there's a third class of planets in our solar system, the dwarf planets, of which Pluto is the first discovered, the brightest, and the largest. As it turns out, and you can see in this diagram, there are many of them, and they're a very heterogeneous population. They have different colors, different surface compositions. Most do not have atmospheres. Some, like Pluto, do. They have different numbers of satellites, ranging from 0 to Pluto is the record holder at 5 currently. And what's perhaps most interesting to me is that the number of dwarf planets that are already known outnumbers the combined population of the terrestrial planets and the giant planets. It's really a revolution in planetary science. And we who are representing the mission and telling you about it today in these two panels are so proud to be able to carry the torch of exploration and the torch of knowledge to illuminate these new worlds. If I can have the next view graph, it was this revolution that I just described, the third zone of the solar system, a third class of planets, and the domineering population, that there are so many of the dwarf planets, that caused the National Academy of Sciences Decadal Survey of 2003 to catapult this mission and to catapult this science to the top of the priority queue for the New Frontiers program. And as a result, this mission was funded by Congress and the administration, and New Horizons was built. If I can have the next time step, I want to talk a little bit about our team. And in fact, there are a number of team members in the audience, engineers, scientists, mission operations, and mission management people. And this group just represents the much larger team that has worked on New Horizons since its inception. I have to tell you, a lot of people thought we couldn't do it, and yet we did. And this team gets all the credit. They work nights and weekends relentlessly to build the mission and to test it, and they have flown it skillfully across 3 billion miles of space to be on Pluto's doorstep. And the team consists not just of all the men and women who've worked so hard over these years, but also a great variety of organizations And I can't name them all, but I just want to name a few of the team members. I want to start, of course, with NASA, because this is NASA's New Horizons mission. I also want to mention the Department of Energy, because as you will hear later, they are pivotal to our ability to explore the outer solar system by providing power supplies that work at these great distances. In industry, there's, of course, the core team members of the New Horizons team, the Southwest Research Institute and the Johns Hopkins Applied Physics Lab. But additionally, there are companies like Ball Aerospace and Lockheed Martin and Aerojet and many others, large and small, across the United States that contributed to this program. Over time, over 2,500 Americans worked to build and fly this spacecraft and to launch its rocket. And I can't tell you how proud I am of the people that have worked on this and made this possible, and how grateful we are as a science team, the people who've got us all this way to Pluto's doorstep. Now let me turn to the spacecraft and the payload and give you a brief overview. You'll be hearing more from other speakers later, in fact, beginning with Bill McKinnon next. But if I can have the next time step. This is a small, compact, highly advanced spacecraft, a real 21st century exploration spacecraft with tremendous capability that's in almost the most wonderful place you could ever imagine you could be as a scientist. The spacecraft is in perfect health, it's full of fuel, and it's carrying a scientific arsenal of 7 instruments that are, combined, the most powerful suite of scientific instruments ever brought to bear on the first reconnaissance of a new planet. Nothing like this has been done in a quarter century, and nothing like this is planned by any space agency ever again. This is a real moment in time for you to watch us turn, as I said, a point of light into a planet. You'll hear more about the individual capabilities of these instruments, but I just want to point out 2 metrics about them that give you a feeling for the technology that's involved. If you weighed all 7 instruments aboard New Horizons, the combined weight of these 7 very advanced instruments is less than just the camera on the Cassini-Saturn orbiter. And if they were all running at once, they would draw only 28 watts, about half a standard 60-watt light bulb. Isn't that amazing? I never get over that. It's a real tribute to the engineers and the foresight of NASA with those 1990s studies to create these advanced instruments that could go on a small compact spacecraft at very high speed to cross our solar system. Now that I've told you about the spacecraft and just a little about its payload, I want to say something about our target, Pluto, and the Pluto system. So I'll take the next step and tell you this is a scientific wonderland, as I just said. It is a binary. Pluto and its large Texas-sized moon Charon, half its size, are like nothing we have ever visited in the history of planetary exploration. And surrounding that binary is a circumbinary system of at least 4 more, much smaller moons. Pluto itself is a very complex body, as Bill McKinnon will tell you about. It has an atmosphere, it has seasons. The surface markings have been moving over time, probably indicating shifting snows and some sort of process of exchange between the atmosphere and the surface. We've seen the atmospheric pressure double or perhaps triple over time while we've been observing it from the Earth. We know that it's rocky on the inside and icy on the outside, and that it has a whole variety, in fact, 3 different surface volatiles, nitrogen, carbon monoxide, and methane, that make for probably the most complex system of interactions we have ever seen in the history of exploration between surface and atmosphere. And then there's Charon, the rising star of this mission. What we used to think of as just Pluto's only moon, now the largest, the other half the binary, but which is completely different. To our knowledge, it has no volatiles on its surface, only water ice. It has a much less rocky interior. To our knowledge, it has no atmosphere. But there are tantalizing signs of surface activity. And in just a matter of weeks and months, as we zoom up on the Pluto system this summer, we're going to see which of those things is actually the case and what this pair has in store for us. We're also going to study the 4 small satellites. Next time step. Let's go to the next time step. And I want to show you an absolutely amazing image made by the Hubble Space Telescope across 3 billion miles of space. This pixelated image, made by the biggest, baddest tool in our inventory, the Hubble, is the best picture of Pluto itself ever made. And you can't see very much detail. In fact, if this were a picture of the Earth at the same pixelation, you wouldn't be able to see the continents. And this is to illustrate how little we know in April. And the next image is to tell you a little bit about how much we will come to know by this summer. The image on the left is typical of the images that New Horizons will be obtaining of Pluto on approach in the final weeks in early July and mid-July of this summer. And the inset, the blow-up, if you will, that shows a portion of New York City, made at the same resolution as our best images of Pluto, as if New Horizons had flown over New York and looked down from the same altitude, reveals amazing detail. You can not only pick out the Hudson and Manhattan in the East River, but you can see Central Park. If you look closely, you can see the wharfs on the Hudson. That's the kind of detail that New Horizons is going to deliver. So we're really about to have a revolution in our knowledge. I'd like to go to the next time step and briefly summarize the objectives, the scientific objectives of this encounter, which you'll be hearing about. And to begin, I'd like to say it's a 6-month encounter that actually started in January. We've been doing environmental monitoring with 3 of the instruments on board to understand the space environment out there in the Kuiper Belt where Pluto orbits. And just last week, we began to turn our attention to the Pluto system. The color image that Jim Green showed you a little bit earlier is evidence of that. We're beginning to make high-resolution panchromatic as well as color images. Spectroscopy will come online shortly as we start to probe Pluto's composition. And in the coming weeks, you'll be seeing more and more imagery resulting from this. But by the time that we are done, we will have mapped Pluto and Charon and the small moons for their geology. We will have mapped their surface temperatures and their surface compositions. We will measure Pluto's atmosphere, determine its structure, its escape rate, and its composition. We will address whether Pluto or Charon have interior oceans, and they might. We will search for new satellites and possible rings in the system, and we'll do more, but I hope I'm giving you a feel that there's going to be a rich variety of data sets about this strange and mysterious system, and we're just so excited. I'm going to close by showing the next time step to give you a bird's eye view of the entire encounter, which, as I said, began in January and lasts through July. We're currently in April, and as I said, turning our attention now to the scientific study of Pluto, not just its environment. But in addition, we're also intensely involved in navigation to home in on the exact aim point that you'll hear about later that we want to hit to maximize the science, an aim point deep in the heart of the Pluto system. Coupled with that is not just the ability to find out where we're going, but to correct our course. And so you see that we have a half a dozen opportunities to trim our course with our engines to precisely target that aim point. And as Jim alluded to a little bit earlier, we are flying into the unknown. And in the second panel, we'll talk a little bit about that. We'll be looking for hazards on approach and downloading images from the spacecraft on the scene to assess whether there are more moons or rings that might present hazards. And we'll talk quite a bit more about that in the second panel. Then, following the apex of the encounter on July 14th, the spacecraft will primarily turn to downlinking all the data that it's collected. And in fact, this mission was designed to collect enormous amounts of data at the system. So much data, in fact, that it will take us 16 months to get it all to the ground. The rest of 2015 and most of 2016 will be filled with new data sets landing on Earth from New Horizons and the science team making new discoveries and discussing them with all of you. We're so looking forward to what we're about to do. We've come such a long way, and we are on Pluto's doorstep. I want Bill McKinnon now to take over and tell us a little bit more about this wondrous system we're headed to. Bill?
Thank you, Alan. So, I'm going to talk about why we're going to Pluto. And if I could have the first slide. The scientific reasons are many. Fundamentally, we're going to Pluto because it's the human race's first opportunity to explore an entirely new class of world. That is, these are the small, icy planets of the Kuiper Belt. And we're going to Pluto because, of course, it's the most well-known, it's the largest, and it's the most complex of all of these small planets. And this cartoon shows you some of the diverse phenomena we hope to study. We anticipate that there will be very complicated geology. We know Pluto has an atmosphere. It's actually a nitrogen atmosphere, just like our own here on Earth. This atmosphere is freezing to frost in some places and evaporating back to gas in other places. And we also want to find, and you look at those arrows all around Pluto, part of the atmosphere is actually escaping off into space and mixing with the solar wind. So we want to understand this very important process of atmospheric escape. We also want to understand as much as we can what lies beneath, because even though Pluto's icy on its surface, it's actually about half rock in terms of volume. So we think it has a rock core, and it may even have a liquid ocean, even today. But Pluto's not on its own. If I could have the next slide. Pluto has 5 moons, 4 of which we didn't even know about when we started the New Horizons project. And these moons all orbit in a plane, and they all go in the same direction around Pluto. So the Pluto is actually like a miniature planetary system. And the details, the architectural details of this system are fascinating. And they'll tell us about Pluto's origin, and they'll also tell us about the conditions in the ancient Kuiper Belt where Pluto formed. And at the heart of the Pluto system, in the next step, is of course Pluto, but also its big moon. The moon is as big as Texas, and in fact we think of Pluto and Charon as actually a binary planet. And the closest thing in the rest of the solar system is the Earth and its moon. It's not quite a binary, but it's almost. And there's really a link between our planet and Pluto, because we think that both our moon and Charon formed in a colossal giant impact, of course, obviously in different places, but it's the same formation process. So what I'm going to show you next is a video, a supercomputer simulation. We can roll that. And this was created by Dr. Robin Knupp at the Southwest Research Institute in Boulder, and it shows 2 Pluto-like objects colliding kind of off-center, and then material is spinning around and being distorted by tides. And over the course of maybe a little more than a day, most of the material collects in the center. That we identify with Pluto. And there's a final blob that goes into a stable orbit, and that we identify with the big moon, Charon. And if your vision is really sharp, you'll see a lot of little blue specks in the background of this graphic. And those are icy fragments. And those will make a disk. And from that disk will be born all of the small satellites. The 4 we know about, and maybe more that we hope to discover with the New Horizon cameras. Now, in the next time step, collisions, like I just showed you, were probably quite common in the early Kuiper Belt. But in fact, there's still a lot of bodies in the Kuiper Belt. You can actually see here the trajectory of the New Horizons spacecraft crossing the orbits of the giant planets. All of those small dots are actually, there are hundreds of thousands of them, maybe millions of them. Most of them are small, like comets. But there are some major bodies, small planets, like Pluto, and some of them are even labeled in that figure. So the New Horizons mission is the first one knowingly sent to explore this new realm of the solar system. Next time step. And as we do that, by exploring the Pluto system, we can then learn more about the other bodies, the other major bodies, which are only telescopic points of light to us right now. Like in the upper left there, Eris. It's a Pluto-sized world, but it's so far from the sun, its atmosphere is completely frozen out. Or in the upper right, Make. It's kind of a Pluto Junior, whose nitrogen atmosphere has escaped because of the lower gravity, because it's smaller, leaving only methane ice behind, which has basically turned red from embarrassment. And at the lower left, there's Haumea, a small planet that has suffered an even more catastrophic collision than Pluto underwent. And all of these worlds, as an ensemble, inform even a broader perspective on the solar system, because you see down in the lower right is in fact the largest asteroid and also considered a small planet. That's Ceres. It's smaller than the worlds I've just been talking about, but we also think on the inside it's very icy, just like bodies in the Kuiper Belt. And right now, NASA also has a spacecraft orbiting series called Dawn. Next time step. Now that's the big picture about scientific ideas, exploration. But of course, in order to have this mission, NASA set out some stipulations about specific objectives for any spacecraft that would go to Pluto. We have what we call Group 1, or the things that any mission must accomplish. These are requirements. And things like that you might imagine. You want to really understand the global geology of Pluto. You want to understand the composition of the entire surface of both Pluto, Charon, and any new moons. You want to understand the atmosphere, both its composition and structure, and also measure its escape. Okay. And of course, we're going to do that. We get a big check. We wouldn't have been picked to do this mission if we weren't going to do those things. But that's just the Group 1. Next step. There's a whole lot of important science that we can also do. We will be searching for the time variability that Alan talked about on the surface. We'll be doing stereo imaging so we get topography of these worlds. We'll be taking very high resolution images. We'll be not just measuring the composition of the atmosphere, kind of like the nitrogen and the methane and things like that, but we'll be looking for really interesting minor components like hydrocarbons. And of course, we're going to do all of these things. So that's another big check. And finally, there's Group 3. Next step. These are things that are just good to do, but you don't have to do to have a successful mission. So we just call those desired. But, and that's stuff like looking for new satellites, searching for interactions of a possible magnetic field with the solar wind. But you know what? We're going to do that too. We're going to do all three. Okay, the required, the important, and the desired. And how are we going to do this? Well, next and my last step. Just as Alan said, we have a most remarkable machine. It has unprecedented capabilities for the first reconnaissance of a new planet. And what you see in this picture is the New Horizons spacecraft and 7 scientific instruments. And so I'd just like to say just a few words about each of them. Down at the 7 o'clock position is our long-range imager, okay? This takes black and white pictures, but at very high resolution. And this is stuff I think everybody in this audience and out there in social media space will be very interested in. And of course, the team will be fascinated too. We also have instruments to measure the solar wind and the charged particle environment around Pluto. We call those SWAP and PEPSI. Up at the top there is the radio antenna, the radio science experiment. Of course, that's used for communication with the Earth. But we also pass radio waves from the spacecraft to the Earth and back through the atmosphere of Pluto. And this will give us the pressure and temperature profile. And we can point the radio dish right at Pluto and Charon and take the surface temperature directly. Down there around 4 and 5 o'clock are 2 more imagers. One is called ALICE. This is an ultraviolet spectrograph. And so now we will actually look at starlight and, in fact, the sun's light passing through the atmosphere of Pluto. And this is how we determine the composition of the atmosphere in exquisite detail. And then Ralph is actually 2 cameras in one. One is the color camera. That was the source, in fact, of the color image that Jim Green showed you just a few minutes ago. And then along with that is LISA, which is an infrared camera. And that's how we determine the composition of the surface materials. And at the very bottom there is, in fact, a wonderful instrument built by students at the University of Colorado. It's a dust counter, and we use this to track the impact and amount of very tiny dust motes all through the solar system, from the inner solar system through the realm of the giant planets and out into the third zone. So I speak for the entire science team in that we are thrilled to be truly on final approach to Pluto. And I'm now going to turn over the dais to Kathy Olkin, who will tell you about what data is coming down when.
That's right. Good afternoon. I'm really excited to be here talking to you about New Horizons and especially about what data will be coming down when. I'm going to start with an overview. So you got to see the image that Dr. Jim Green revealed this afternoon, which was our first ever color image of Pluto and Charon taken from New Horizons. As you could see, Pluto is still a point of light from our vantage point in the solar system. But starting in May, Pluto will get the highest resolution images ever, and it's going to get better every day from there. Every day we travel almost 1 million miles closer to Pluto. So it's going to be really exciting. Each day is going to reveal something new. One highlight will be in mid-July. In mid-July, we'll have our closest approach, and some of the data sets that we'll bring down will have a resolution of about 1/4 of a mile on Pluto and its largest moon, Charon. That's going to be really exciting to see. But as you've heard, it's going to take a long time to get the data down. Near closest approach, New Horizons is filling our recorders with all the data that we can fit. It's about 60 gigabits. And at the distance of Pluto, it takes a while to return data. So it's going to have to wait, and we'll be sending data down all the way out until the end of October 2016. We're going to have surprises and discoveries over the next year and a half as Pluto reveals itself with each and every DSN pass. Next time step. As you heard, there's a great diversity of the science data that we'll be taking with New Horizons to study Pluto, its moons, and its environment. We're already getting imaging data down from the LORRI instrument and the Ralph instrument and plasma data. In May and June, we will begin atmospheric studies and composition studies of the surface ices. In July, we're going to be hitting Pluto with everything we have. That's going to be showtime. So we're going to be bringing down specific observations that we're choosing to sample the diversity of the Pluto system in that time period. But as I mentioned before, not everything can come down in July. Physics just doesn't allow that. So in August, you can see from the graphic that we're just going to be bringing down plasma data. There's a really good reason for that. We have a very small operations team, and our team needs to keep our eye on the ball when we're flying by Pluto to make sure that we make the most of this historic encounter. And to that, in August, the data that comes down in August needs to be commanded back in June and July. And so it's really important that we make it easy for our team to concentrate on getting the most out of Pluto. And therefore, in August, what you'll see coming down from New Horizons will be plasma data, because that's the easiest to send to the ground. Then in September, we'll pick up again with the full diversity of the science data set that we have coming down. And it will continue coming down until late in 2016. Next time step. So I'm sure you all are really interested in what's going to come down during the week of encounter. The week of encounter is the week of July 12th. Our closest approach is July 14th. And we're going to be bringing down a huge variety of data which tells us about the temperatures on Pluto, detailed atmospheric studies. Some parts of that data set will come down, compositional maps of both Pluto and Charon. We're going to be getting plasma data down. We're going to be looking at geologic and color imaging. This image here on the slide shows you Manhattan at about a 1/4 mile resolution. This is what we'll be getting down during the week of closest approach. So we'll be able to see great detail on Pluto and Charon, well beyond what we see today as these worlds of just points of light. It's going to be really exciting. So one thing I also want to point out is that on the actual closest approach day, we will not be bringing back any imaging data. We need to keep our sights on Pluto. We need to train our instruments on Pluto, and that means we're not taking time to send data back down to Earth. And so on closest approach day, we're all going to have to be patient while New Horizons is exploring Pluto. Next time step. I want to tell you a little bit about the long data downlink after our encounter. I've already spoke some about the plasma downlink in August. In the middle of September, we're going to have a 1-week time period where we bring down selected high-priority data sets. These are things that we really want to get to the ground to help fill out our early studies of what Pluto, Charon, and its moons look like. Then, starting in late September, early October, we will be bringing down what we call our browse data set. This is all of our observations, but at a lower resolution, so we can get them down more quickly. So this will be able to come down in about 2 months. We'll get everything down, but at a lower resolution. Then finally, in late November, we will start our full resolution playback. This is our high resolution data. Every image that's on the spacecraft will be brought down at full resolution, and that is what really takes the longest time period to bring down. It's those 60 gigabits of data that we're filling up the recorders with, and that will be played back all through 2016. So come along with us while we explore the third zone of our solar system. Thank you.
Well, thank you. Now we're going to transition into our question and answer period. I'm going to do something a little different here. We're going to first go to the phone lines. A number of folks are watching us on NASA television and on our website, www.nasa.gov. And for social media, a lot of buzz out there. Keep sending your questions in. We'll try to get to as many as we can today at #AskNASA. And for folks who are just joining us, this is one of two panels we will have, so don't change that remote. We'll be coming back to you with the second part at 2:30. And I see a wide range of ages in our audience today, and if we have time, we'll see if any of our public here who've joined us here at NASA headquarters has a question on this incredible mission. So let's go to the phone lines first, and Eric Berger from Houston Chronicle.
Yes, hello. Thanks so much for doing this. This is really a historic opportunity for a lot of people who have never seen a planet, even a dwarf planet, sort of revealed for the first time, and this may be the last time sort of there's this opportunity to see a new world, sort of laid bare for us with images and temperature and all kinds of interesting data. Could someone there maybe speak to that, sort of the really interesting experience and unique experience this is going to offer the world?
Sure. Well, many of us were alive during the time and even participated in the Voyagers, and that was just truly exciting. The computer systems were as nearly as sophisticated as we have now, and there were a lot of printouts coming back and images and instant science, even though many of the scientists felt very uncomfortable about making proclamations about what they see in the data. We're going to experience all that and more when we do the encounter here. So indeed, this will be a little deja vu for some of us, but indeed, it's one of the most exciting steps that we can take for NASA in planetary science.
Eric, I thought that was a great question, a great perspective, and so let me just add that I agree with you. In a real sense, there's nothing like it in the world. What NASA's doing with New Horizons is unprecedented in our time, and probably something close to the last train to Clarksville, the last picture show for a very, very long time. I actually did a little research with the Census Bureau data a couple of years ago and asked the question, how many people in this country probably don't remember Voyager? They weren't born, they were too young to have ever seen a first-time flyby like we're going to do with Pluto. And surprisingly, it turned out that if I did the numbers right, it's about half the people in the United States and probably about half the people across the world have never seen anything like this before. So you're absolutely right in this perspective that it's really unique. There hasn't been anything like it for a long time and nothing like it coming again.
Okay, next caller is Alan Boyle from NBC. Alan?
Thank you. This might be for Alan Stern. Just on the plan to share the images on the web, will they be sent to a website, probably Pluto or Pluto, JHU, APL, or maybe NASA, as soon as they're received, or is there going to be a lag time? Could you just tell us what the plan is going to be for distributing images? Thank you.
Sure, thank you, Alan. Let me tell you a little about that, but let me also say it's a work in progress, and we haven't quite pinned down exactly how we're going to be doing that. We still have a little bit of time while the images are more or less dots in the distance, if you will. We're going to be posting imagery from the LORRI high-resolution camera on the web, on a number of websites, including the project website, and of course, NASA's going to be leading with NASA websites as well. We'll probably want to look at those images after they land on the ground before we post them so that we can add captions about image artifacts and potentially announce discoveries as well. So it won't be instantaneously loaded to the computer because we want to take a look first and make sure that we understand the data a little bit. But our goal is to make it very fast and responsive and to make it a way that people can join in by looking every day and every week as we make the approach to Pluto.
Yeah, the top website to look at first would be www.nasa.gov/New Horizons.
Jim, I'm glad you said that. I was going to say that same thing. Okay, so let's go to social media now. Lots of buzz on that. My colleague from Applied Physics Lab Communications, Mike Buckley. Mike, what's going on in the Twitter and social media world?
A lot of commentary on the pictures that are out now, seeing those first color views of Pluto and Charon. Got a lot of people excited. And some questions too. So this is one from Sky Safari Astro, who wants to know, will the data from different instruments on New Horizons be combined to learn new information about Pluto?
Well, of course. I mean, we'll be looking, correlating where the infrared spectra and the visible color and black and white images all overlap. So we're really trying to identify where the individual ices and individual hydrocarbon or any rock regions on either of these bodies, Pluto or Charon, lie, as an example.
And I'll just add to that with another example. In studying Pluto's atmosphere with the ALICE ultraviolet spectrometer that Bill spoke about, as we watch the sunset through Pluto's atmosphere to determine its composition and density as a function of altitude, we believe from the modeling that's been done that eventually the sunlight will be entirely extinguished by absorptions, chemical absorptions in the atmosphere. And so there'll come an altitude at which the ALICE spectrometer can't probe below. But we'll be using our radio experiment, REX, with that transmission from the Deep Space Network that Bill spoke about, which we'll be able to see all the way down to the surface, not with the same compositional capabilities, but to continue the temperature and pressure profile all the way down to the hard deck.
And I'll just even add more to that. Even as we understand the composition of Pluto's atmosphere from the ultraviolet spectrometer, we'll actually be flying through the escaping part of the atmosphere and be sampling it directly with the SWAP and PEPSI instruments.
Yeah, and I'd like to add that you can't fully understand this complex world without looking at it as a whole. The surface ices, the temperature of the surface ices support the atmosphere and what the atmospheric pressure is. So we're going to need to look at the whole system to understand it in detail.
Okay, Mike, let's take one more. I know there's a lot coming in, and we've got some other media from across the country want to call in, and I'm going to see if we can take some questions here in the audience before we reach our bewitching hour and we have to transition for our next panel. But Mike, what we got?
Okay, we'll look a little bit beyond Pluto for a second. This is a question from Neo Vlek, who wanted to know that after a successful mission to Pluto, what kind of work could New Horizons continue to do along the lines of maybe Voyager 1 and 2?
Kick that off, or you?
I'll be happy to. What's happened over the last couple of years is the team has turned its attention, parts of the team have turned its attention to looking at the Kuiper Belt and actually discovered more than 50 Kuiper Belt objects. Now that search has been quite extensive. They've used every major ground-based facility, and they've also used a lot of space-based facilities. And most recently, Hubble spacecraft, the Hubble Space Telescope, was used to look deep beyond Pluto, look into the Kuiper Belt. And the whole objective is there a Kuiper Belt object that may be along one of the trajectories that New Horizons could get to? And indeed, Hubble bore the fruit that the team was looking for, and there are two candidate objects. So right now, the team is turning its attention and all of its attention to make this encounter successful. But afterwards, they will be given an opportunity to propose to NASA to go on to one of those two objects.
And I'll add to Jim's great answer that those two objects are each about 1 billion miles further beyond Pluto, with a travel time of approximately 3.5 or a little bit longer years, depending upon which target. And in addition to exploring a Kuiper Belt object, if our proposal for an extended mission is successful, we can, as the questioner asked, also add to the kind of data that Voyager is generating on the space environment. SWAP and PEPSI, the dust counter built by the students, some of the other instruments as well, being very advanced compared to the 1970s technology of previous spacecraft, can be much more sensitive to that space environment and add to that library of knowledge too as the spacecraft flies outward further and further and further from the sun at its high speed.
Okay, let's go to the phone lines. Then we'll come here to see if we have any questions. We're going to have to conclude at the top of the hour. And my apologies. I understand we're getting a lot of questions in from social media. We'll get to those throughout the day as soon as possible. So let's go to the phone lines. And Pete Spots, Christian Science Monitor. Pete?
Oh, thank you very much. This is for Dr. Stern, I think. You mentioned that this is a generation that has never seen a mission like this before. At the same time, this is also the generation whose imagination has been captivated by extrasolar planets. And how would you respond to someone who'd say, well, this is nice, kind of batting cleanup on our solar system, but we've got this whole new horizon of extrasolar planets on our platter. Are there synergies between the studies of the two that New Horizons might contribute to? How would you encourage people with the extrasolar planet buzz to stay tuned to this one?
Oh, that's a really great question. And let me say that in the study of planets, we have had a complete revolution since the 1990s. Here at home in our own solar system with the discovery of the Kuiper Belt and small Kuiper Belt planets, dwarf planets that we've been discussing here, and which it's the objective of New Horizons to make the first reconnaissance of. But then from ground-based and then space-based observatories like Kepler, discovering that planetary systems are common around stars and that there are many more types of planets than we see just in our own solar system, with pulsar planets and hot Jupiters and super Earths and quite a number of other varieties. And so between what's going on in our solar system and what's going on out in the study of extrasolar planets, we're seeing that our early notions, the time that I grew up and was educated, went to graduate school and studied planets, there were only two types. They were either rocky terrestrial worlds or they were giant planets like Jupiter out to Neptune. And now we see that that was really a data-limited perspective, that the variety is exploding, almost as if instead you were a biologist who was trapped on a desert island for a long time, and then your knowledge, limited by only the biology on that one island, expanded by being able with new technology to go to other places around the Earth and see how vast the variety is. So I think the two things are complementary. We're exploring with telescopes at NASA in Earth orbit and from the ground extrasolar planets and learning tremendously exciting things about it. And at our home solar system, actually going and traveling out to our discovery of a new type of planet with New Horizons.
Yes, I'd like to comment on this, if I may. This is really a foundational mission. What we're going to be doing here is looking at very primitive bodies that were left over from the initial origin of our solar system. And these are very important to understand. It can tell us all kinds of things about how that process occurred and how these objects may have moved around throughout the solar system, because we believe at one time the solar system did indeed rearrange itself, pushing Neptune and Uranus out into the Kuiper Belt and bringing some of those objects in. So as a foundational mission, it enables us to interpret planets around other stars, knowing that these type of objects must also exist out there. And I think it's also important to note that, at least in our lifetime, I don't believe we'll be able to look at exoplanets like we're going to look at Pluto. We're not going to be able to look at the surfaces at this resolution. So we really need to be able to take advantage of what we want to learn here in our solar system, and then that will naturally be applied to the extrasolar planets.
Bill, Kathy, you want to add to that?
I think, Jim, you basically captured what I was going to say.
Yeah.
Just the point is that, in fact, the discovery and exploration of the Kuiper Belt is a great complement to exoplanets, because the Kuiper Belt itself is where the evidence lies that our solar system has not been static. Like we were all taught when we were young on this panel that the giant planets formed where they were and they sat there for the rest of time. But it isn't so. They've probably migrated. Their orbits have evolved, and we see evidence of that also in the hot Jupiters and other kinds of exoplanets out there in space. So it's It's a whole new perspective on planet formation.
Just one more connection. In the work that's been done by telescopes on the ground and in space by NASA, we found Kuiper Belt analogs around other stars. And so that's a direct connection to the mission that we're doing and gives us a chance in our home solar system to provide the kind of resolution that Jim talked about, which will be a very long time coming for systems so far away.
Okay, we're going to take one more call for the media that are watching and on the phone. We will make the New Horizons team available for follow-up interviews. Also, Dr. John Grunsfeld will be available, as I said at the beginning. This is his vast portfolio of almost 100 missions. Pluto New Horizons is in his portfolio, so send those interview requests in, and we'll get the appropriate folks to answer them. So Frank Mooring from Aviation Week, and then we're going to bring it back here and close out. Frank?
Thank you. This is kind of an operational question. I wonder if you can tell me what the time lag is for commanding and receiving on the day of the flyby, and how much of your data collection is pre-programmed, and whether you have the possibility of adjusting it as you see things as you close in on the planet. And the same question then in terms of returning the data after you fly by. Thank you.
Yes, I'm happy to answer that. So the time it takes the signal to go from Earth to the spacecraft is about 4.5 hours. So that's a very long time. And near encounter, everything is pre-programmed. We pre-program the sequences of observations we'll take. We pre-program the compression and downlink of the data that's coming down. This is all pre-planned because we don't have time to be commanding all the time. We don't want to be spending time looking at Earth, receiving those signals. So that is all pre-planned. If there were an emergency, we could change that, but that is the current plan.
And the other aspect of the pre-planning is it allows us to thoroughly test the sequences, which have been done both on spacecraft simulators many times, as well as actually putting the very close approach sequence up on New Horizons in both 2012 and 2013 and letting the spacecraft actually go through its paces as if it were 2015. And so we've taken care to make sure that we have a bulletproof sequence that's been thoroughly vetted and that we know will work there at the Pluto system. Now, on the downlink, it's a little bit different. As we downlink data and we find particularly interesting data sets that might tell us that the next thing we'd like to get down next month might be a little bit different than our preconceived notions, we'll have more flexibility with that.
Okay. Unfortunately, we're going to have to close out and transition to our 2:30 briefing. Today, you have been listening to the Pluto New Horizons, the science, the images that are coming down, and at 2:30, we'll get more involved into the design, construction, and other components of the spacecraft, and also some challenges that the New Horizons team will be facing. I would like to say, save the date, July 14th. And to piggyback off of Dr. Green's deja vu moment, we all remember, the world remembers the Curiosity landing, where you were. Ladies and gentlemen, you will remember Pluto flyby. Thanks for joining us. We'll see you at 2:30. Goodbye.